In this video, we are going to continue to learn about factoring. First thing that we're going to talk about is a sum and difference of two cubes. So sum is when you are adding, so that would be this rule down here. And difference is when you are subtracting, so that would be this rule right here. Whenever you are doing this, two things are being cubed. So let's see what is happening with example 1. I have x cubed minus 8. The first thing you want to do is figure out what is being cubed. So something is being cubed here and something is being cubed here. So x cubed is x cubed and 2 cubed is 8. So when I'm looking at this, I see that I'm subtracting. So I'm going to be using the difference of 2 cubes rule over here. Because I am subtracting, here x is going to represent, x is going to represent the x in the rule, and 2 is going to represent the y in the rule. So again, I'm using this rule that is right here. So I'm going to have x minus 2 times x squared is just x squared plus x times 2 is 2x plus 2 squared is 4. Once you factor using the rule, you want to make sure that you have factored completely. X minus 2 is linear. Remember back in Algebra 1, you learned about, if the highest exponent of the variable is 0, then you have a constant. If your highest exponent that you have of a variable is 1, then it's linear. If the highest degree of the variable is 2, then it's quadratic. If the highest degree is 3, then it's cubic, and so on. So for this example, x minus 2, this is linear because the highest degree of x is 1. Whenever you have a linear factor, that's factored completely. For this trinomial over here, my highest degree is 2. So this one is quadratic. So you'd want to make sure that this is factored completely. If I tried to do the area model for this, we would be looking for factors of 4 that add to 2. No such factors exist. So this one is factored completely. Let's try example 2. Here I have a sum. I know that because I am adding. So I'd be looking at this rule down here. Next, I need to figure out what is being cubed in the first term and what is being cubed in the second term. Well, 3x is being cubed in that first term, and 4 is being cubed in that second term. If you don't know your perfect cubes off the top of your head, that's fine. You can use a calculator to check it. So in your calculator, you would do, the cube root of 27 and the cube root of 64. So in your calculator, if you're using a TI calculator, you would hit the math button. And then I think it's number 4. Number 4, I think, is the cube root. And you would be able to get that way. Or you can use Desmos and you can just click on the cube root button in Desmos. So when I go to factor this, x is going to be represented by 3x and y is going to be represented by 4. Because this is a sum of 2 cubes, I am going to be using this rule right here. So let's do that. So I'm going to have x plus y. So it's going to be 3x plus 4 times x squared. So x is 3x. 3x squared would be 3 squared times x squared, which is 9x squared, minus 3x times 4. Well, 3x times 4 is just 12x, plus y squared. Well, here y is 4. 4 squared is 16. Oops, 16. You always want to make sure that you have factored completely. 3x plus 4 is linear, so I know this one is factored completely. 9x squared minus 12x plus 16. If I were to try to factor this, 9 times 16 is 144. So that would mean that we're looking for factors of 144 that add to negative 12. There are no such factors that exist. So this one is factored completely. Let's try example 3. Here I have a difference. I know that because I'm subtracting. So I'll be using this top rule here. Now I need to figure out what is being cubed in this first term and what is being cubed in the second term. Well, let's see. It looks like y cubed is y cubed and 1 cubed is 1. So when I go to plug into this formula, x will be represented by y and y will be represented by 1. So I will have x minus 1, x squared is x squared, plus x times y, so y times 1 is just y. Whoops. I mixed up my x's and my y's. I prefer when this rule is written out with a's and b's for that reason. Let's try that again. So x minus y, or x plus y. Whoops, we're doing the difference. X minus y. So that's going to be y minus 1 times x squared would be y squared plus x times y. Y times 1 is just y plus y squared. Y is 1. 1 squared is 1. Y minus 1 is linear, so that one's already factored. If you try to factor this quadratic, you'd be looking for factors of 1 that add to 1. No such factors that exist, so this is your final answer. Now let's move on to factoring by grouping. So here you'll notice that we have 4 terms, and you've only ever been used to factoring with 3 terms. To factor when you have 4 terms, we're going to do something called factoring by grouping. Your first step is the same as always. You always want to look for greatest common factor. Here, I do not have one. It should be noted that you should have also been looking for a greatest common factor up here. None of these had one, so that's why we just jumped straight to using those rules. So on example 1 for factoring by grouping, I do not have a GCF. So I am going to go straight to my area model. Now, there is just one difference when you have 4 terms as opposed to when you only have 3 terms. Here, I have 4 terms and 4 boxes. So we are just going to put each one of those 4 terms in the box. So I'm going to have x squared or x cubed. I'm going to put the second term in the second box, the third term in the third box, and the fourth term in the fourth box. From here, I'm going to find the greatest common factor of each row and of each column. The greatest common factor in my top row is x squared. The greatest common factor in the bottom row is 7. The greatest common factor in the left column is x. and the greatest common factor in the right column is 6. Remember that the wonderful thing about factoring is that you can always check your work. X squared times x is x cubed. X squared times 6 is 6x squared. 7 times x is 7x, and 7 times 6 is 42. So my factors are x squared plus 7 times x plus 6. You always want to make sure that you have factored completely. In this first term, I have x squared plus 7. It's only 2 terms, so the only way I could factor this is if this was a difference of 2 squares. It's not a difference of 2 squares because, first of all, I'm adding. That's not a difference. Second of all, 7 is not a perfect square. So this factor is factored completely. With x plus 6, this factor is linear, so I know that one's factored completely. So this is my final answer. Let's try the same thing with number 2. With number 2, my greatest common factor, well, let's look and see. Looks like my greatest common factor is 6. So I'm going to want to go ahead and factor that out to start. So I'll have in parentheses x cubed plus 5x squared minus 3x, and then I think that's 15. Let's see. 90 divided by 6 is 15. Well, now I want to factor completely. So now I'm going to factor what's remaining inside the parentheses using the area model. I'm going to take each one of those 4 terms and put it in each one of the empty boxes of the area model. The greatest common factor of my top row is x squared. The greatest common factor of the bottom row is negative 3. The greatest common factor of the left side is x, and the greatest common factor of the right side is 5. Let's check our work. X squared times x is x cubed. X squared times 5 is 5x squared. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. So right now, my factors are 6 from my greatest common factor times x squared minus 3 times x plus 5. I want to check to see if each one of these factors is factored completely. Well, 6 is just a constant, so there's nothing left to factor there. Here I have a difference and it's quadratic. So let's check to see if this is a difference of 2 squares. Well, x is a perfect square, right? Because x squared is x squared. But nothing squared is 3. There is no integer squared that will give me 3, so this is not a difference of 2 squares, so I can't factor this any further. On this third factor, x plus 5, this factor is linear, so there's nothing left to factor there. So this is my final answer. Let's try example 3. The first thing that we want to do is we want to look for a greatest common factor, and here I do not have one. So then I can go straight to the area model. I'm going to take the first term, put it in the first box, second term in the second box, third term in the third box, fourth term in the fourth box. And now I want to factor the greatest common factor for each row and of each column. The greatest common factor of the top row is y squared. The greatest common factor of the bottom row is negative 9. The greatest common factor of the left column is y. And the greatest common factor of the right column is 4. So right now I have y squared minus 9 times y plus 4. Now we want to check to see if we have factored completely. Well, y squared minus 9. This is a difference of 2 squares. I can see that because, let's look and see what's being squared in each part. So here, y is being squared for y squared, and 3 is being squared for 9. So I can factor that as y plus 3 times y minus 3. Y plus 4 is a linear factor, so that one is factored completely. So this would be my answer for number 3. Let's try the same thing with example 4. There is no GCF. So I can go straight to the area model. I'm just going to take each one of my 4 terms and put them in each one of those boxes. The greatest common factor of the top row is x cubed. The greatest common factor of the bottom row is 1. The greatest common factor of the left column is x, and the greatest common factor of the right column is 1. So I have x cubed plus 1 times x plus 1. Now I want to factor completely. This first term is a sum of 2 cubes. I know that because I can see something is being cubed here and something is being cubed here. Here, x cubed is x cubed and 1 cubed is 1 cubed. So I am going to use a rule for the sum of 2 cubes. So I will have x plus 1 times x squared is x squared minus x times 1 is 1x plus 1 squared is 1. And then this factor is linear, so that one is factored completely. All of my factors are factored completely, so you could write your answer like this. Or you could recognize that you have 2 identical factors. X plus 1 times x plus 1, I could rewrite that as x plus 1 squared times x squared minus x plus 1. And this would be my answer.